Fine. Let's start. Number 16. The sun is destroying itself. Right now, while you're sitting there, the sun is committing a slow and spectacular act of self-destruction. Every single second, it takes about 600 million tons of hydrogen and crushes it into roughly 596 million tons of helium. And if you're paying attention, those numbers don't add up. 4 million tons have gone missing. Every second. That missing mass didn't vanish. It became light. It became heat. It became the exact warmth on your skin the last time you stood outside on a clear afternoon. The sun is quite literally converting 4 million tons of itself into pure energy every second, and it has been doing this without a single pause for about 4.5 billion years. Let that scale settle for a moment. 4 million tons is a mountain. Picture a mountain of the sun's own body being annihilated, gone, turned into radiation, once per second, since before the Earth had oceans, since before there was anything alive to look up and feel it. Here's the thing we don't like to sit with. The light that keeps every living thing on this planet breathing is not a gift. It's the exhaust of something enormous, slowly killing itself. The sun is a furnace, eating its own walls to stay lit. And it's not going to stop being unsettling when you hear the reassuring part. Scientists will tell you, correctly, that even at 4 million tons a second, the sun has lost only a tiny fraction of 1% of its total mass over its entire life. It's so massive that this cosmic hemorrhage barely registers. It has another 5 billion years of fuel to burn. But run the tape forward far enough, and the arithmetic becomes personal. The fuel is finite. The fusion that gives us daylight is also a countdown. One day, the hydrogen thins out, the core changes, and the sun begins the long process of becoming something that will not be kind to Earth at all. So the next time someone tells you the sun came up, remember what actually happened. A star tore 4 million tons out of itself, 60 times a minute, so that a little of it could fall on your face. We built our whole existence on top of a controlled catastrophe, and we call it a nice day. The star we owe everything to is spending itself to give us light, and it will keep spending until there's nothing left to give. Number 15. The planet that is shrinking. We tend to think of planets as permanent. Fixed, the kind of thing that was here before us and will be here after us, unchanged. Mercury would like a word. The smallest planet in our solar system is shrinking. Not metaphorically. The entire world is physically getting smaller, and it has been for a very long time. The reason is buried at its heart. Mercury has an enormous iron core, and that core is slowly cooling. When metal cools, it contracts. And when the core of an entire planet contracts, the crust wrapped around it suddenly has too much surface for the volume underneath. So it does the only thing it can. It buckles. It cracks. It folds over on itself. Across Mercury's surface, you can see the scars of this. They're called lobate scarps, and they're gigantic cliffs where one slab of crust has been shoved up and over another. The largest mapped example, Enterprise Rupes, runs for about 1,000 kilometers and rises more than 3 kilometers in places. That's a wrinkle on a planet, tall enough to swallow mountains. Estimates of how much Mercury has shrunk vary. Some studies say its radius has dropped by a kilometer or two. Others push it towards 7 kilometers. The whole planet, drawing inward like a piece of fruit slowly drying out. And here's the part that genuinely gets under your skin. When NASA's Messenger spacecraft looked closely at those cliffs, it found some of them look young, geologically fresh, which means Mercury probably isn't finished. The shrinking may still be happening today, right now, cracking the crust in slow motion while we watch from 100 million kilometers away. That discovery put Mercury in a very small club. For a long time, we thought Earth was the only tectonically active rocky planet. The only one where the surface still moves and breaks. Mercury quietly joined it, A dead-looking gray ball that turns out to still be flexing and fracturing. There's something quietly disturbing about it. We look at a planet and read permanence, solidity. But Mercury is a reminder that worlds cool, worlds contract, worlds age. They are not the fixed backdrop we imagine. They are objects with a lifespan, wrinkling as the heat leaks out of them. Somewhere out there, a whole planet is slowly cracking under its own cooling, and it will keep cracking long after everyone reading this is gone. Nothing up there is standing still. It only looks that way because we don't live long enough to see it move. Number 14. The light older than civilization. You already know that sunlight takes about 8 minutes to reach us. The sun is roughly 150 million kilometers away. Light is fast, but not infinite. And so the sunrise you see is always 8 minutes old. That's the famous version. It's also the boring version. Because the 8 minutes is only the last, easy stretch of the journey. The real story happens before the light ever leaves the sun at all. A photon is born deep in the sun's core, in the fusion furnace, carrying a burst of energy. And then it tries to leave. The problem is that the inside of the sun is not empty. It's plasma-packed 13 times denser than lead. Our photon travels about 1 centimeter before it slams into a particle, gets absorbed, and is spat back out again in a completely random direction. Then it does it again. And again, and again. Millions upon millions of times. It's not flying outward in a straight line. It's staggering through the densest fog imaginable, 1 tiny centimeter at a time, in random directions, like a drunk trying to cross a stadium and forgetting which way the exit is after every step. Physicists call this a random walk. And when you do the math on how long it takes energy to random walk its way out of the sun's radiative zone, the answer is staggering. Estimates range from about 10,000 years to as much as 170,000 years. Sit with that. The energy in the sunlight warming your face today began fighting its way out of the sun's core back when our ancestors were still chipping stone tools. It has been trapped inside a star, bouncing for longer than human civilization has existed. Only in the outer layers does it finally break free, cross the vacuum in 8 minutes, and land on you. So here's the uncomfortable poetry of it. Every sunbeam is ancient. The warmth on your skin is tens of thousands of years old, forged before the pyramids, before writing, before agriculture, and it spent almost that entire time imprisoned in plasma before slipping out in its final few minutes. There's something haunting about being warmed by light that old. It makes the sun feel less like a lamp switched on this morning, and more like a vault, slowly leaking energy that was sealed inside it before we had language. The next sunrise you catch, you're not seeing something new. You're seeing something released. A little piece of the deep past, finally escaping, just in time to touch you and be gone. Number 13. The sky that rains diamonds. Somewhere on Neptune, right now, it is raining diamonds. Not sparkling metaphors. Actual, solid diamonds, falling through the sky. Neptune and Uranus are the ice giants, the 2 blue worlds at the far edge of our solar system, and they hide something strange in their guts. Their atmospheres are rich in methane, and methane is built from carbon and hydrogen. Near the surface, that's just gas. But as you sink deeper into these planets, the pressure climbs to unimaginable levels. Thousands of kilometers down, the squeeze becomes so violent that it tears the methane apart, rips the carbon loose, and then crushes those bare carbon atoms together into crystal, into diamond. And these diamonds don't just form and hang there. They're denser than the material around them, so they do what anything heavy does. They sink. Scientists think diamonds drizzle downward through the interior of these planets, a slow glittering hail falling toward the core, possibly building up into a layer of diamond thousands of kilometers beneath the clouds. For years, this was a beautiful theory that no one could test, because nobody can drop a probe into the crushing interior of Neptune and live to report back. So in 2017, physicists did the next best thing. At the SLAC laboratory and Lawrence Livermore, they took plastic, which is also made of carbon and hydrogen, and hit it with shock waves to recreate the exact pressures inside an ice giant. And they watched diamonds form. In an instant, nearly every carbon atom in the sample snapped together into tiny nanodiamonds, right there in the lab, in the time it takes light to cross a room. The fantasy turned out to be real chemistry. Here's the twist that flips it from wondrous to unsettling. It sounds like paradise, a planet raining jewels. But there is no place on Neptune you could ever stand to collect them. The same pressure that manufactures the diamonds would flatten you, cook you, and dissolve you long before you got near them. It is a treasure vault with walls that would kill anything that tried to reach it. That's the recurring lesson of the cosmos. The universe is full of things that are genuinely, jaw-droppingly beautiful, and almost every one of them is lethal up close. A sky raining diamonds sounds like a wish. It's actually one of the most hostile environments imaginable, sparkling in the dark. Beauty and death, wearing the same face. On Neptune, they fall together, forever, and no one will ever hold a single stone. Number 12, the planet where it rains, glass sideways. If diamond rain didn't do it, meet HD 189733b. From a distance, it might be the most beautiful planet we've ever found. It's a deep, rich cobalt blue, a color so Earth-like that the first time you see it, some quiet part of your brain relaxes. It looks like home. It is the opposite of home. This planet sits about 63 light years away, and it's what astronomers call a hot Jupiter, a giant gas world orbiting scandalously close to its star. So close that its atmosphere is superheated past 1,000 degrees Celsius. And that gorgeous blue color, the one that fools your eye into comfort, is not water. It's not sky. It's glass. The atmosphere is laced with silicate particles, tiny grains of glass suspended in the air. In the brutal heat of the dayside, glass vaporizes. The winds then carry that vapor around the planet, and where it cools, it condenses back into droplets and falls as rain. A rain of molten glass. But it doesn't fall gently, and this is where it stops being a curiosity and starts being a nightmare. The winds on HD 189733b scream at up to 5,400 miles per hour. That's roughly 7 times the speed of sound, so the glass doesn't drift down. It flies sideways, horizontally, like a storm of molten razor blades moving faster than any bullet you've ever heard of. Try to actually picture standing there, a blistering blue world where the wind alone would shred you, and it's carrying a sideways monsoon of liquid glass hot enough to melt through anything. There is no umbrella for that. There is no shelter. The prettiest planet in the sky is a machine for flaying whatever enters it. And here's the detail that lingers. The blue we find so soothing, the exact shade that makes it look like a peaceful ocean world, comes from the glass itself. The thing that makes it beautiful is the thing that makes it deadly. They are the same substance. You cannot separate the postcard from the horror. We keep hoping that out there, somewhere, we'll find a world that looks like ours and turns out to be as gentle as ours. HD 189733b is the universe's answer to that hope. It painted a planet the perfect calming blue, and then filled it with sideways glass and supersonic wind, just to remind us that appearances mean nothing at all in space. Blue does not mean safe. Out here, blue can mean the knives are coming sideways. Number 11. The moon that rains fuel. Here's a world that will unsettle you in a stranger way, because it's not alien enough. It's too familiar. Titan is the largest moon of Saturn, and it is the only other place in the entire solar system with liquid on its surface right now, forming rivers, lakes, and seas. It has clouds. It has rain. Rain falls from those clouds, gathers into streams. The streams carve channels. The channels feed into vast dark seas, some of them bigger than any of the Great Lakes. It has weather. It has a coastline. It has shorelines and river deltas that, in silhouette, look eerily like a satellite photo of Earth. And then you learn what it's all made of. None of that liquid is water. On Titan, the temperature is about minus 179 degrees Celsius, cold enough that water is frozen rock hard. Water ice is literally the bedrock, the solid ground, hard as granite. The rivers and seas that flow over that ground are liquid methane and ethane. In other words, the rain falling on Titan is essentially the same stuff that comes out of a gas pipe. It rains fuel. Picture it, a world running the exact same cycle we do. Methane evaporates off the seas, forms clouds, drifts, cools, and falls back as rain. It pools into rivers. It carves valleys. It fills lakes and slowly evaporates again. It's Earth's water cycle, faithfully reproduced, except every drop is flammable, and the whole place is colder than anything you have ever felt. We know this isn't a guess, because we went. In 2005, the European Huygens probe descended through Titan's thick orange haze and landed on the surface. Its cameras sent back images of drainage channels and what looked like a dried riverbed, a floodplain waiting for the next methane rain. The Cassini spacecraft mapped over 1.5 million square kilometers of Titan's lakes and seas from orbit. Here's the part that quietly disturbs. Titan isn't frightening because it's monstrous. It's frightening because it's a near-perfect copy of home, assembled entirely from the wrong ingredients. It's an uncanny valley the size of a moon. Everything is where it should be: rivers, rain, coastlines, and every single piece of it is poison and cold and gasoline. It's a mirror of Earth held up in the outer solar system, and the reflection is all wrong. Familiar enough to make you homesick, alien enough to kill you in seconds. A place that looks like where we live, built out of everything we could never live in. Number 10. The ghosts passing through you. You feel solid. You feel like a closed, sealed thing. A body with an inside and an outside, and a clear border between you and the universe. That feeling is a lie, and here's the proof. At this exact moment, about 100 trillion neutrinos are passing straight through your body. Not around you, through your skull, your heart, your bones, every cell, and out the other side. And in the second it took you to read that sentence, an entirely fresh 100 trillion did it again. Neutrinos are ghost particles. They're born in the nuclear fusion at the heart of the sun, the same reactions making all that sunlight, and they come flooding out in almost unimaginable numbers. Roughly 100 trillion of them cross every square meter of the Earth every second. They are the most abundant particle with mass in the universe, and they are streaming through you constantly. The reason you feel nothing, the reason you've never once noticed, is that neutrinos barely interact with anything at all. They ignore ordinary matter almost completely. To a neutrino, you are not a solid object. You are not even really there. You are a faint smudge of mostly empty space that it slips through without so much as a nudge, the way a ghost drifts through a wall in an old story. Except this is real, and it's happening trillions of times a second inside your chest. Now here's the detail that turns it genuinely eerie. It doesn't stop at night. When the sun goes down and it's on the other side of the planet, those neutrinos don't get blocked by 8,000 kilometers of solid Earth. They pour right through the entire planet and come up through the floor, through your bed, through you, from below. There is no hiding from them. There is no shielding. Whole mountains, The entire mass of the world might as well be glass. We build detectors to catch them, giant tanks of water or ice buried deep underground. And even then, they only manage to snag a tiny handful out of the countless trillions that pass by. Almost all of them go through the whole Earth and out into space, having noticed nothing, having touched nothing. So the next time you feel safe inside your own skin, remember, you are not a wall. You are not sealed. The universe is pouring through you right now, 100 trillion ghosts a second, and neither of you will ever feel a thing. You are far more empty and far more transparent than you have ever let yourself believe. Number 9, the twin that is hell. We spend a lot of time and money searching for a second Earth, a twin world, roughly our size, in the right place. Here's the thing. We already found one. It's next door, and it is the closest thing to hell that physics can build. Venus is almost exactly Earth's size. Same rough mass, same rough diameter, formed from the same material, in the same neighborhood, at the same time. On paper, it's our sister planet. In reality, it's a warning. Start with the heat. The surface of Venus sits at about 465 degrees Celsius. That is not just hot. That is hot enough to melt lead. Everywhere. All the time. Day and night. Pole to equator. The entire surface glows at a temperature that would liquefy metal. There is no cool spot, no shade, nowhere to run. Then add the pressure. The atmosphere of Venus is so thick and heavy that at the surface it presses down with about 90 times the force of Earth's air. That's the pressure you'd feel nearly a kilometer deep in our ocean. Standing on Venus, you wouldn't just cook. You would be crushed, flattened by an ocean of air pushing on every inch of you at once. And if the heat and the crushing weren't enough, look up. The clouds of Venus are not water. They're sulfuric acid. It rains acid in the upper atmosphere, though the drops boil away before they ever reach that scorching ground. We know exactly how deadly this combination is, because we tried to visit. The Soviet Venera landers touched down on Venus decades ago, and these were tough machines, built like tanks specifically to survive. They lasted about an hour, maybe 2, before the heat and pressure and acid killed them, and the signal went dead. An hour. That's the lifespan of our best hardware on our nearest twin. Here's why Venus should genuinely disturb you, more than any distant exotic world. Scientists think Venus may once have had liquid water. Oceans, maybe. A place that could have been mild. And then a runaway greenhouse effect took hold. The carbon dioxide trapped the heat. The heat released more gas, and the whole thing spiraled until the oceans boiled away, and the planet became the furnace it is now. Venus isn't just a hostile alien world. It's a case study. A planet that started out a lot like ours and became a lead-melting, bone-crushing, acid-wrapped hell. It's sitting right next to us. The same size, the same age, quietly demonstrating exactly how thin the line is between a home and an oven. Number 8, the emptiness inside you. Che. We've talked about how empty space is. Now let's talk about how empty you are. Because the truth about what you're made of is stranger than anything happening in a distant nebula. You are made of atoms. Trillions upon trillions of them. And an atom, the fundamental building block of you and everything you've ever touched, is almost entirely nothing. At the center sits a tiny nucleus, and orbiting far, far away is a thin haze of electrons. In between, empty space, and not a little. An atom is more than 99.9999% empty. To get a sense of the ratio, imagine the nucleus of an atom blown up to the size of a marble and set on the 50-yard line of a football stadium. The electrons would be tiny specks whirling around somewhere up in the nosebleed seats. And everything in between, the entire stadium, would be empty. That is what you are made of. Stadiums of nothing, stacked trillions deep. Here's the fact that really lands. If you could somehow squeeze all that empty space out of every atom and every human being alive on Earth right now, all 8 billion of us, the leftover solid matter would fit inside a single sugar cube. The entire human species, compressed down to something you could hold between 2 fingers. But, and this is the part that makes it beautifully horrifying, that sugar cube would still weigh what 8 billion people weigh. Hundreds of millions of tons, crammed into a couple of cubic centimeters. All the mass, none of the space. Which raises a genuinely disturbing question. If you're almost entirely empty, why do you feel solid? Why doesn't your hand pass through the table? The answer is that you never actually touch anything. Ever. When you press your hand against a surface, the electrons in your skin and the electrons in the surface repel each other with electromagnetic force. What you feel as solid, as contact, as the reassuring firmness of the world, is just force fields pushing back. You have never made contact with a single object in your entire life. You've hovered a hair's breadth away, held off by invisible repulsion, every single time. So the ground under your feet, the chair you're in, the phone in your hand, and your own body are all overwhelmingly empty, held together and held apart by forces you can't see. Solidity is a sensation, not a fact. You are a cloud of mostly nothing, convinced you're a thing. And you've spent your whole life certain you were touching a world you've never once actually reached. Number 7. The place colder than space. Here's something that shouldn't be possible. There is a place in the universe that is colder than empty space itself. Colder than the background chill of the cosmos. Colder than the leftover warmth of the Big Bang. And it's a place a dying star made on purpose, without meaning to. Start with the baseline. Space is not actually zero temperature. Even in the emptiest void between galaxies, there's a faint, uniform warmth left over from the birth of the universe, the cosmic microwave background. It sits at about 2.73 degrees above absolute zero. That is the natural floor. That leftover glow soaks everything, everywhere. You cannot, just by drifting in the dark, get colder than the universe's own background temperature. That's supposed to be the coldest anything gets on its own. The Boomerang Nebula never got the memo. About 5,000 light years away, there's a dying star throwing off its outer layers, and it's doing it violently. A wind of gas is blasting away from that star at something like 500,000 kilometers per hour, and when a gas expands that fast, it cools. It's the same physics as the chill of a spray can when you hold the nozzle down, just cranked to a cosmic extreme. That expansion has chilled the Boomerang Nebula down to about 1 degree above absolute zero, 1 Kelvin, which means this dying cloud is colder than the cosmic microwave background around it. It is, as far as we know, the single coldest natural place in the entire universe, colder than the empty space it's sitting in. Think about how backwards that is. The nebula is refrigerating itself below the temperature of the void. It's like finding a pond in the desert that's somehow colder than the coldest night the desert has ever had. Nature reached beneath its own floor. We only found this because in 1995, astronomers pointed the right telescope at it and got a reading that didn't make sense, a temperature lower than the background it was supposed to be bathed in. The Boomerang is a genuine outlier, a fluke of a dying star expanding at just the right insane speed to out-chill the cosmos. And here's the quiet, lonely part. It won't last. As the gas keeps spreading and thinning, it'll eventually warm back up to match the universe around it. For a brief cosmic moment, in the outflow of something dying, the universe produced a pocket of cold deeper than it should be able to. The coldest place that exists is a star's final breath, and even that will fade back into the ordinary chill of everything. Number 6. the invisible wanderers. Everything we've talked about so far, you could at least point to. You know where the sun is, where Venus is, where Neptune is. This one is different, because the whole problem is that you can't see it, and you can't point to it, and it might be closer than you'd ever want to know. Our galaxy is haunted. Scattered through the Milky Way, drifting between the stars, there are somewhere on the order of 100 million black holes. Some estimates push it as high as 170 million. Not at the center. Not in some distant region. Everywhere. Wandering, alone, through the same galaxy we live in. These are stellar mass black holes, the corpses of massive stars that collapsed at the end of their lives. And here's what makes them so unnerving. Most of them are completely dark. A black hole only lights up when it's actively feeding, tearing gas off a nearby companion and heating it until it glows in X-rays. But a black hole drifting alone, with nothing to eat, gives off nothing. No glow, no X-rays, no warning. It is a region of pure gravity moving silently through space, and there is currently no reliable way to see one coming. For a long time, these rogue black holes were purely theoretical. We were sure they had to exist, but we couldn't catch one. Then, in 2022, we finally confirmed the nearest known example. It's called Gaia BH1, and it sits about 1,560 light-years away. We only found it because a perfectly ordinary star was orbiting something invisible, circling a patch of empty space where a black hole about 10 times the mass of the sun was hiding, silent and dark. 1,560 light-years is comfortably far. That's not the scary part. The scary part is what its discovery implies. If the closest one was completely invisible until 2022, if we could only spot it by watching a star dance around nothing, then how many more are out there, closer, that we simply haven't noticed yet? By definition, we can't see the dark ones. We can only find the rare ones that happen to have a partner to give them away. There could be one drifting through our region of the galaxy right now, and we would have no idea. It wouldn't announce itself. It wouldn't glow. It would just be there, a knot of gravity in the dark, moving on its own long orbit around the galaxy, indifferent to everything. The universe isn't only vast and cold. It's also full of things you cannot see, and some of them are black holes, and they are already among us. Number 5, the body that falls apart. We dream about living in space stations, colonies, a future among the stars. But there's a problem nobody puts on the poster. The human body was built by gravity, for gravity, and the moment you take gravity away, it starts quietly falling apart. Start with something almost charming. In orbit, astronauts get taller. Without gravity compressing your spine all day, the discs between your vertebrae expand, and your whole spinal column stretches out. Astronauts come home up to 2 inches taller than when they left. NASA has to account for it, leaving extra room in flight suits so people literally grow into them. It sounds like a fun bonus. It's actually the first sign that your body structure is being pulled out of shape. Now the parts that aren't charming. Your bones need the constant load of gravity to know they matter. Take that load away, and they start dissolving themselves. Astronauts lose about 1% of their bone density every single month in space if they don't fight it, leaching calcium out of their skeletons. On Earth, that kind of bone loss is a disease. Up there, it's just Tuesday. Your muscles go the same way. They weaken because they no longer have to hold you up against anything. On long missions, astronauts can lose up to 30% of their muscle mass. That's why they spend hours strapped into exercise machines every day, not to get fit, but just to slow down the wasting. And then there's your heart. Down here, your heart works constantly to pump blood upward against gravity. In orbit, it doesn't have to fight anymore, so it gets lazy. It actually starts to shrink and become more spherical, deconditioning like any muscle that stops being used. Your blood volume drops. Fluids that gravity normally pulls down into your legs float up into your chest and head, puffing up astronauts' faces. Put it all together, and you get an unsettling picture. The instant you remove weight, your body reads the situation as, we don't need all this anymore. Bones, muscle, heart, all of it starts downsizing, disassembling the very machinery that keeps you alive, because the pull it was designed around has vanished. The height comes back within days of landing. The bone loss might not. Some of it can be permanent. And that's just for a stay on a space station orbiting close to home, which raises a grim question about our dreams of the stars. We talk about a future in space as if the only obstacles are engines and rockets. But the truth is, we haven't solved the most basic problem of all. Out there, away from gravity, we slowly come undone. The body itself is the thing that isn't ready. Number 4, the moat of radiation. If your body coming apart in orbit wasn't enough, there's something else waiting just above your head. Earth is wrapped in a moat, an invisible ring of radiation so fierce it could kill an unprotected astronaut, and it's been floating up there this whole time. They're called the Van Allen belts, and they're one of the stranger consequences of living on a magnetic planet. Earth's magnetic field is what protects us from a lot of the sun's incoming radiation. It's a shield, and mostly it's a very good one. But that shield doesn't just deflect dangerous particles away. It also catches some of them and holds on to them, trapping them in 2 enormous donut-shaped zones that encircle the entire planet. Those zones are the Van Allen belts, and they are swarming with high-energy charged particles, moving at ferocious speeds. Any human who lingered in the heart of them, unshielded, would absorb a dangerous, potentially deadly dose of radiation. The belts sit above us, wrapped all the way around the world, a permanent halo of the very stuff our magnetic field is supposed to protect us from. Here's the irony that should genuinely stop you. The magnetic field that makes Earth safe enough for life, the thing without which the solar wind would have stripped our atmosphere away long ago, is the same thing that traps a ring of lethal radiation directly over our heads. The shield has a sting built into it, protection and danger in the same structure. And this isn't abstract. It's a real barrier we've had to physically deal with. When the Apollo astronauts went to the moon, they had to fly straight through the Van Allen belts to get there. NASA's solution was simple and a little terrifying. They plotted a path through the thinnest part of the belts, and they went through fast. The Apollo 11 crew spent only about 52 minutes crossing them, minimizing how much radiation they soaked up, keeping the dose down to something survivable. 52 minutes. That was the plan. Sprint through the radioactive moat before it can hurt you, and don't stop. There's something quietly menacing about it. We look up at a clear blue sky and see openness, freedom, the way out to the stars. But the way out isn't open at all. It's guarded. Just beyond the sky is a belt of trapped radiation that we have to time our escape through, threading a gap, racing the clock. Earth doesn't just sit in space. It sits inside its own fortress, ringed by an invisible moat of its own making, and everything that leaves has to run the gauntlet on the way out. Number 3, the syndrome that blinds. We're getting to the ones that really stay with you. And this one is quiet and slow, and it's happening to the handful of humans we've sent to live in space the longest. Space is stealing their eyesight. It has a clinical name, spaceflight-associated neuroocular syndrome, and the reason it exists comes back to gravity again. On Earth, gravity is constantly pulling the fluids in your body downward, keeping everything balanced. In orbit, that downward pull is gone, so the fluids in your body, blood, and the cerebrospinal fluid around your brain drift upward and pool in your head. That's why astronauts have those puffy faces. but the puffiness is just the visible symptom. The real damage is happening behind the eyes. All that extra fluid raises the pressure inside the skull, and that pressure presses on the back of the eyeballs. Over weeks and months, it physically deforms them. It flattens the back of the eyeball, the part that's supposed to be a smooth curve. It swells the optic nerve where it enters the eye. It folds the retina. The eye, an instrument tuned over millions of years of evolution to a precise shape, gets quietly warped by the pressure of its own fluids with nowhere to drain. The result is that astronauts' vision changes. Many come back more far-sighted than when they left, their eyes reshaped by the mission. And here's the part that turns it from a curiosity into a genuine concern. Some of these changes don't fully go away. The flattening, the folds, the shifts in vision can persist after they return to Earth, even after gravity should have set everything right again. NASA takes this seriously enough that it's rated one of the top human health risks for a mission to Mars. Think about why. A trip to Mars means months and months in weightlessness, far longer than most stays on the space station, with no option to turn back. If the eye keeps deforming the whole way, if the pressure keeps building over a journey that long, we genuinely don't know how bad it could get. We've never kept a human weightless long enough to find out. That's the quietly frightening part. This isn't a dramatic explosion or a sudden failure. It's a slow, creeping change. The body's own plumbing, slowly bending one of its most delicate organs out of true, and we don't yet have a way to stop it. The longer we stay up there, the more space asks in return. And it turns out one of the first things it quietly takes, from the people who go the farthest, is their clear sight of the very stars they went to reach. Number 2. The star we can never reach. Here's the one that isn't violent, or gruesome, or hot, or cold. It's just a distance. And somehow that makes it worse, because there's nothing to fight. There's just the gap, and the gap wins. The nearest star to our sun is called Proxima Centauri. It's a small red dwarf, and on the cosmic scale, it is right next door. It's our closest possible neighbor, the very first stop on any journey out into the galaxy. It sits about 4.24 light years away. 4.24 light years. It sounds almost reachable, friendly even. But let's turn that distance into something human and watch it become a wall. We have built fast machines. The fastest is Voyager 1, the probe we launched in the 1970s, now hurtling out of the solar system at about 60,000 kilometers per hour. Nothing we've ever made has gone faster on its way to the stars. So let's say you climbed aboard something moving at Voyager's speed and pointed it straight at Proxima Centauri. How long is the trip? About 73,000 years. Sit with that number. 73,000 years to reach the closest star there is on our fastest machine. That's not a career. That's not a lifetime. That's longer than our entire recorded history, many times over. It's more than 2,500 human generations, born and living and dying, one after another, on a ship that is still not there. Everyone who waved goodbye at launch would be an ancient legend before the ship crossed even a fraction of the way. And this is the easy one. This is the closest star, the shortest possible interstellar trip, the absolute best case. Every other star is farther. The vast majority are hundreds, thousands, millions of times farther still. That's the quiet horror hiding inside all our dreams of space. We imagine ourselves as a species that will one day spread among the stars, hopping from world to world. But the honest arithmetic says we are marooned. We are on an island, and the nearest other island is so far across the dark that our fastest boat would take longer than civilization itself to reach it. The stars look close. On a clear night, they feel like you could almost touch them, but that closeness is a trick of the light. In reality, we are stranded on a single rock, around a single star, held in place not by any wall or barrier, but by distance so vast that it might as well be infinite. The galaxy is right there, and we cannot get there. That's the loneliest fact in the sky. Number 1. The edge where time ends. And so we come to the last one. The one that doesn't just threaten your body or your dreams, but breaks the thing you trust most without ever thinking about it. Time. Because at the edge of a black hole, time itself stops having a single answer, and what happens to a person there is 2 contradictory deaths at once. Let's say you fall in, feet first, toward a black hole. The first thing that gets you is gravity, but not the way you'd expect. A black hole's pull is so extreme that the difference in gravity between your feet and your head becomes enormous. Your feet, closer in, are yanked harder than your head, and so you stretch. You are pulled longer and thinner and longer still, drawn out into a thread of a human being, atom by atom. Physicists, with a dark sense of humor, call it spaghettification. You don't fall into a black hole so much as you are drawn into it, like a strand of pasta, pulled to infinity. That alone is a nightmare, but it's not the part that should truly unsettle you. The part that breaks your brain is what happens to time. From your own point of view, falling in, everything feels normal. Your watch ticks at its usual pace. You cross the boundary, the event horizon, the point of no return, in a finite amount of time, and, for a large enough black hole, you might not even feel the exact moment you pass it. From the inside, it just happens. You fall, and then you're across. But now imagine someone watching you from a safe distance, and here is where reality splits. To them, you never cross. As you approach the edge, the black hole's gravity warps time so severely that they see your clock slowing down. You fall slower, and slower, and slower. Your image dims, reddens, stretching toward the deepest infrared, and then fading out entirely. And you freeze. To the outside universe, you hang there at the edge, motionless, dimming, never quite falling in, for the entire remaining lifetime of the cosmos. So which is it? Did you fall in seconds? Or are you frozen at the edge forever? And the answer, the genuinely mind-bending answer, is that both are true. There is no single universal clock that settles it. Your time and their time are different, equally real slices of the same reality, and they simply do not agree. There is no fact of the matter about when you fell in. That's the deepest, quietest horror in all of space. Not that it can kill you. Everything out here can kill you. It's that at the edge of a black hole, the universe stops being able to answer the simplest question there is. When? There is no when anymore. There is only your when, and their when, and an eternal, silent disagreement between them, hanging forever at the edge of the dark. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.